out.
Yeah, I
with
have
the-
those. I've got those, so that's nice. But still, sometimes it's not. Still kind of
It's
up
not.
in
They're
the
not
air.
real clear.
Yeah, yeah. So, okay, we'll go to number 5. Student project compared to the effective. Oh, you go ahead.
Oh no, go right ahead. You're going. Go for it.
A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They wanted to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate for this analysis?
There's 2 things. And I said, yeah, we're up.
I would probably say,
What month was that called? For a year.
geez, I don't know.
Paired sample t-test?
Yeah, there's just 2, so I was assuming it was paired something. Or 2 of something. Yes, ma'am. Can't be ANOVA's too many. And it's not proportions. So it's either paired samples t-test or that's it.
Paired samples t-test.
Yep.
Well, there's like one study group, and then they had them do 2 things. So is it like a independent sample t-test? Because it's kind of like if they're in the first group, they're in the second group anyways. You know what I mean?
Right.
There's just one group of students. So it'd be independent because it doesn't really depend. Like, it didn't say, like, if you're redheaded, the redheads tried the counterclockwise.
Yeah, except they've got one set of students that are trying 2 different locks.
Yeah, so they have to pair it with the student with the one lock. They couldn't, like...
And each student was asked to open both locks.
Right.
So they would have to pair the time, how long it took them with each different lock. That's why it's paired, right?
Right.
And it could be. I thought paired was more of like it was dependent on, so if the student had red hair, then they opened the lock that was counterclockwise. Whereas, so that's like dependent. If you, whether or not you open a counterclockwise lock is dependent upon a certain characteristic or something like that. Whereas this one is just like everybody tried a counterclockwise and a clockwise lock.
Oh, I think I know what you're saying. Hold up. So the independent sample t-test compares the means of 2 independent groups in order to determine whether there is statistical evidence social population measures different.
We could just wing it and someone put paired and someone put independent.
Okay, I'll go with paired.
Oh, I'm 50-50 now.
Yeah. I'll put independent and we'll see which one's right.
Okay, so question 6.
Cool.
A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same type of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval would be most appropriate for this study?
I wish our book would have a chapter on this, on these kind of decisions.
Me too.
I kind of thought it was the paired samples T confidence interval. What do you guys think?
These are very like the same type of properties. Yeah, they do have to. There are two sets of data they have to put together, but I'm sure it's not Z, it's not T, it's not independent. Yeah, but these are paired. I think it's paired. It shouldn't be independent samples t-tests because yeah, like these are actually paired together. So I think
Yeah.
I understand what you meant by question 5 now. You said it's independent sample because yeah, like unless those 12 students were like, unless those 25 students were what's the word? Like yeah, like they were all Asians or they were all blacks or something like that.
In question 5.
Yeah, I think I know what you were saying there too. Because I was just reading the definition of it again.
Right.
I don't know. That one's still 5 is still a toss up between both of them, to be honest. But 6 paired seems like the only one, since they are literally comparing price with property, which those have to be together, right?
I think so. Yeah, we can go with it. So we've got 2 tries on this quiz, right?
Yes, we do.
Good. Yeah, I say we go with that.
Okay, question 7. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reporting for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study? And I thought it was F, the confidence interval for 2 proportions.
There are 2 again. So maybe as like not a rule of thumb, but like to simplify this. So we only do Z if we know the standard deviation, right?
Right.
We do T when actually I don't know when we do T, but we do T. We do T when we're taking
t-test
the
is
average
like
of one group, right, or something.
when you don't know the standard deviation, when it's not given, or if there's 2 groups. But
Okay.
that's with quantitative, or right?
That's quantitative.
Quantitative, and then
Okay.
there's another decision tree for qualitative. So there's categorical. So there's one for quantitative, and then there's one for categorical data.
Okay.
And I really wish I would have attended the class meeting because it probably would have made a lot more sense.
So is this one categorical or quantitative? I want to say
See,
it's
this
categorical. What?
I was going to say this one kind of confused me because they started out talking about the percentage of psychology majors, and then they said, and side by side with that, they reported for accounting majors. And you want to construct a confidence interval to see if the difference is significant. So you'd start that off doing that separately for each category?
I think so, but I think you're right. I think it is the confidence interval for two proportions. I think it's categorical because they're not measuring like numbers; they're measuring satisfied versus not satisfied.
Right. So
You
they,
know what I mean?
yeah.
So I agree with you that it would be two proportions, like confidence interval of two proportions.
Yeah, I agree. Sounds right.
That one
Okay.
makes sense.
Who's got the Oreos?
I'll do it. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is true. That is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreo cookies in order to compare it with the filling amount in regular Oreos. Which confidence intervals would be most appropriate for this study?
I would think that's a one sample T confidence interval.
That's what I got.
You're taking the
They're
sample of
just
two groups, yeah.
trying to find the true mean of double stuffed Oreos.
Yep.
Kind of like we're trying to find the true mean of ounce per price per ounce of a taco.
That's right.
All right. See, there we go.
Ours is a t-test, right?
No, ours isn't a Nova because we have three.
Oh, we have 3 stores, right?
Yeah.
Okay, question 9. Which one of the best defines the notion of the significance level of a hypothesis test?
I feel like this was on the first exam. Still on what?
Oh, that would be a p-value is what A is.
I thought it was the probability of the type 1 error.
Significance level. I'm good with that because the p-value, so p-value is A, right? Probability of zero.
Right.
Yeah. So significance level. Probability of type of error.
What does it mean by the notion? Okay, yeah, it is type 1, huh?
Oh, it actually might be C.
We're probably rejecting the null hypothesis. But isn't that what a type 1 error is?
Level of significance.
Is the type 1 error means you rejected the null when you should have accepted it or something like that? Yeah, because I think the little word at the end changes it. Because it says the probability of rejecting the null hypothesis, whether it's true or not. But technically,
Oh,
you're just trying to see if it's
actually,
true, right?
I think it is. Well,
Is that
I
little
think
word or
that's
not, I think changes.
rejecting the null given that it is true. So it would be a type 1 error.
Yeah.
So the true or not part, if it ended at,
just
if
true,
it's true, then it
then
would be
they'll-
that one. So
Yeah.
I think type 1 error.
Okay.
Oh, hey, number 10. Number 10 is C.
Which is the following notion of the future. Yeah. There it is. That's okay. I've been struggling with number 11 for like forever. Like sometimes I get it right and sometimes I don't.
It's the 95% of all 95% confidence intervals actually contain the true mean.
That's what I got.
I put that before and I got it wrong, and then sometimes I put that and I get it right. It's like I don't
Just remember the 95 and the 95.
put 295s. Okay.
That's really how I remember it. The last class meeting, the TA just described it could be stated as it's stated in the question, or it can be stated as blank percent of all blank confidence intervals actually contain. So that's how I remember.
Okay.
See, it's kind of like a trick question, though, because they throw in that 10 and 20. So,
Yeah.
sneaky little suckers, aren't they?
Okay. Sweet. Number 12. Take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.3 or 30%. What is the mean of the distribution of the sample proportions? Random sample. Isn't it?
Point
0.3?
0.30?
Yeah.
It's 0.3.
Oh, and of course, it doesn't tell us what to round it out to, does it?
I'm just gonna say 3 decimals.
So yeah, the mean of P hat, which is distribution of sample proportions, equals P. So
Okay. What is the standard deviation of the distribution?
of the distribution. So that would be let's see, 0.7. How many did they take? 100. So I got 0.021.
How'd you get that? Sorry.
There's that formula. It's like P times parentheses 1 minus P parentheses divided by N, and that's squared. Or not squared, sorry, square root.
Okay.
So the square root of P times parentheses 1 minus P divided by N.
Okay.
So I actually screwed that up.
And
That's
N
not
is
right.
100, right? N equals 100, right?
Yeah, I square rooted N, so I messed up.
I got 0.046 for this.
That's probably more accurate. Okay, that's what I got.
Okay. That's weird. It's multiple choice on the lesson 20 preparation.
Yes, it is.
It's just on there.
Cool. So did you get that one, Bobby?
Yeah.
Okay, sweet. So 14, what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? Good question. So we got...
So I did the P times P hat minus 0.30 over the 0.046. Less than 0.25 minus 0.30 over the 0.046.
Okay.
And then came up with the 0.138.
Or which formula do you use for that? I'm like so lost all the time.
So I actually just plugged it into the Excel.
What did it say?
And I just used, I don't know if that's right, but I used 30 as X because there's 30% of 100. So I don't know if that's right to do that. But I got the same confidence interval that we got. And that one, the p-value is 0.876. I got the same p-hat, same confidence interval.
Wait, what you got, 13?
So on 13, we got 0.046. Sorry, what did I say? I might have said something different.
Well, just looking at the multiple choice, that's not one of the answers.
Yeah.
Are the numbers the same?
No, there's no point for anything. It's just 0.138, 0.124, 0.876, and 0.862.
Oh, 13's a different question. So
what am I looking at?
Number 12 is the same as our number 13. Because they don't have the first question that we had of like, did you actively participate in?
Oh.
So the question numbers don't exactly match up.
You're one behind, I see.
Yeah.
Okay, so Landon, you have 0.046 for 13.
Yep.
Right?
Yep.
Okay, so we're working on number 14.
So then on 14, I got 0.876.
Ooh, that is on there too.
That is on there, isn't it?
Yep.
And I just used the Excel spreadsheet to figure that one out.
Is that the test of one proportion? Or
yeah, one proportion.
You said X was 30, N was 100?
Yes.
And
then confidence interval doesn't really matter for this question. But then your null hypothesis is that 0.25. And then your type of test is less than. And it would just be your p-value.
Yeah, I got 0.86. I got 0.876 as well.
Okay, we can go with that.
Sweet. Sweet.
Do we have another exam after this, or is it just the final project?
No, we have an exam due tomorrow.
I mean, like after this exam.
Yeah, there's one more after this one.
Oh, okay.
Woo! Do you know if it's cumulative? I mean, they're all kind of cumulative, but
I have no idea.
Yeah, I don't know. That'll be interesting. Okay, cool. Are we good to move on?
Good to move on.
What was
Okay,
that?
so Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. So create a 95% confidence interval for P1 minus P2. Input the margin of error, lower and upper bounds, below rounded to 3 decimal places. Ready,
So
go.
This is the two proportions, I'm assuming.
Yeah, it's supposed to be two proportions. So, one.
I mean, I could just kind of, you could plug it into Excel, but I kind of want to like understand it.
I got.
So do you like divide it like Excel? The people who felt dizzy over the people who didn't feel dizzy, or over the total?
Sorry, what was that?
You put the people who felt dizzy over the total amount of people on the Excel.
I don't think I wrote that down in my notes. I just put it in Excel for that one. Oh, here it is. Oh no, just kidding.
Hey guys, stand by. I got someone at the door. I'll be right back.
Okay.
Okay.
Yeah, I'm not.
I put this in Excel. I just put 61 for X1. I put 61, and then for N I put 1563.
Yep, that's what I put.
And then yeah, with X2 put 15 and 579.
Perfect.
And this should be a type of test not equal to, right? The people who do this.
Yeah. And for the margin of error, it doesn't affect it, the type of test. So
yeah. The only way I've been finding the margin of error has been like you find the middle number between the confidence intervals, right? And then you find like how far away that middle number is from both of them.
right.
And I don't know if that's the proper way to find it, but
I think so. That's what they've done in the past. So you just like take those two, add them together, divide by 2. There's your middle number.
and then you find how far they are from.
Yeah, then you just take like, I've just taken the upper bound minus the middle number, just so I'm dealing with positive numbers the whole time.
Yeah.
And then I just subtract the 2 and get the difference. So for that one, for 15, I got 0.016.
That's what I got too.
Cool. And then
lower bound, upper bound, or just whatever you have.
Yeah, so I got negative For the lower, I got negative 0.003.
Yep. And then upper bound was 0.029.
Yep.
Cool.
Okay, I'm back. Sorry about that.
You're okay.
It's all good.
What did we get?
So on 15, we got 0.016.
Okay.
And you can't really verify that because they didn't do it for the one homework. But I'm pretty sure that's right. I guess we'll see.
Okay, and then they want what? 16. They want the confidence intervals.
16, they want like the lower bound, upper bound.
All right.
So we just used the Excel to proportions tab.
This is gonna be a rough exam, I feel.
And I'm gonna have to do some studying tonight. That's for sure.
Do you guys get 0.04 and 0.29?
No.
Okay, hold on. What did I do wrong?
So the inputs for X1 we put 61. For N1 we put 1563.
Oh, okay. Okay.
And then for X2 we put 15 and N2 we put 579.
Why is this not calculating? All right, I'm going to have to reload my Excel.
You're okay.
I can come back to it. Let's move on.
Okay. Just so you have them, for the lower bound, we put negative 0.003. And then for the upper bound, we got 0.029.
29.
Yep.
0.09?
0.029.
29. Okay, yeah, I had the 29.
What was that? Sorry, you cut out.
Oh, no, I had the 0.29. Okay.
Oh, nice.
Okay, so we're on 18.
Yes.
Okay, perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control subjects who do. Use a level of significance of 0.05. What are the appropriate null and alternative hypothesis?
I'm pretty sure it's A.
That's what I got.
Because didn't
Yeah,
somewhere
your
say,
test.
for these tests, the null will always be equal, and then the alternative will be something else.
Yeah.
Agreed.
So, cool.
Okay, so using that same information, the value of your test statistic.
That's just the p-value? Or
That would be the Z.
Because the p-value is obviously the next one. Sorry.
So the Z is 1.458.
Just realized, yeah, the p-value is the next one.
There you go. Yeah, we still got it though.
My thumb has been killing me. I can't really talk.
So did you just like spike the volleyball super hard? Like,
No, someone spiked it into me.
oh man, that's even worse. Dang.
Yeah. He came up.
Is your finger okay?
I think so. They just said I hyperextended it. Like you extend
Ow.
it, further than it's supposed to. But it only happened for like a second. So it just like flicked back into place, so it just bruised.
Jeez.
Like it left a bruise, and then it wouldn't go away, so I got kind of scared. So
That's intense.
I'm okay now.
So what did they tell you to do for it?
Ice it. Don't use it. That's pretty much all they said.
Pretty generic answer.
Did they tell you to soak it in Epsom salts too?
They did not. What is that?
It does
Epsom
help.
salts. Yeah, Epsom salts is a cure-all for anything. You can get it over the counter at any, Walgreens, Target, any store. Just get a tub of warm water, pour a half a cup of Epsom salts in there, and just soak it. And what it does is it just pulls out all the bad stuff that helps inflame, and a lot of the stuff that kind of bug the nerves that cause a lot of pain on those tendons.
Okay.
It does help.
Okay. Icy salt. I will look it up. I put icy hot on, but it's really hot.
Yeah. No, Epsom salt is good for muscles and tendons, so.
Okay.
That's good. Good stuff.
Cool. Sorry for that distraction.
Anyways, back to 21.
Sorry for that.
It's all good.
Okay, so the p-value of the test is
0.145.
0.145. That's what I got.
Awesome. Cool. So then in 21, is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking acropol is different from the true proportion of the people who experience dizziness while not taking acropol?
Are we going to go with
No.
D on that one?
No, I failed to reject null hypothesis. So I think that's like A, B, C, D, E, F.
A, B, C, D, E, F. Yeah. F.
The last one.
Okay.
Like, you have to do the alphabet. A, B.
I don't know. It's like, which one is that? No. Okay, sweet.
Okay, so for 22, a survey was conducted of 1279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypotheses for this study are: being a morning or evening person is independent of age. Being a morning or evening person is not independent of age. The results of the survey are given here. Conduct a test of independence. Use a level of significance of 0.05. Calculate the test statistic for this hypothesis test. Assume the requirements for the test are satisfied.
This is the chi test, right?
Yeah.
Okay. All right, Excel, help me out here.
All right.
Where we have to enter manually.
Yeah, that's a bummer.
I think it's better than doing the equation ourselves.
I got
6.580.
I got 6.579, so pretty much same thing.
Does it say here to round? Or are we just going to assume that we have to round?
I would say nearest like 3 decimal places.
Yeah, at the very top it says round to 3.
Okay.
Yeah, I got 6.579.
It's interesting because on the review in the book, the answer closest is 6.580.
Really? Huh. That's odd. That's just
Yeah.
the same thing. They just rounded to the second decimal place. I don't know why they did that. I mean,
Well, you guys want to try 7.9? I'll try 5.80.
sure.
Okay.
I think we'll both get it right because I'm pretty sure they give you some leeway.
That's true. They might do that.
Unless we're wrong, but I'm pretty.
We'll find out.
Okay. Awesome. 23.
Cool. So 23, I got 0.087.
That's what I got.
Me too.
Should you reject or not? Or I guess fail to reject.
Yeah, you failed to reject. So, no.
Should you reject? No, the p-value is greater than 0.05.
So 24 is D.
Yes.
I feel like these questions, I don't know. Are we more used to the ones that are like, we failed to reject because blah, 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 blah. That's why this is kind of tripping me out how it's so simplified.
Yeah, and they're worded very differently too, so.
Oh, there it is, 25.
So that one would be.
Yep. Insufficient evidence, right? Because
Yeah, so that'd be C. What was our null?
Okay, yeah. Insufficient evidence say that being a one person maybe is independent.
Morning or evening person is independent. Oh, so I think it would actually be D.
What was the null? Being a morning or evening person is independent of age.
So it would mean we have insufficient evidence to say that being a morning or evening person is not independent of age. We don't have sufficient evidence to say that it isn't.
Oh, okay. I see what you're saying. Cool.
Sweet. Hey,
Okay, 26.
just a heads up. I might have to sneak out for a few minutes. Someone's coming to tour our condo real quick. So, just so you know, if I stop talking, I don't know if someone's here, but they will be here sometime soon. So,
Okay.
anyway,
It's a busy
just
night.
so you know. But we can go ahead. We can go ahead to 26. Sorry.
Okay, 26. A recent book noted that only 20% of all investment managers outperformed the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of the sample, create a 95% confidence interval of P and put the lower and upper bounds below rounded to 3 decimal places.
So what kind of test is it? Is it one proportion or FPV true proportion?
So let's say, yeah, right, 50 out of these 200. So if we do that, my lower bound is 0.190.
That's what I got too.
My upper bound is 0.310.
That's what I got.
Oh, I'm sorry. I totally missed out. You guys say?
So for 26, if you use that one proportion tab, and your X would be 50 and your N would be 200 at a 95% confidence interval, we got lower bound of 0.19 and upper of 0.31.
Would the null hypothesis? Oh, it's 95. Huh? Whoop. Wait.
Well, your null hypothesis doesn't really matter for this test for the confidence intervals. So
yeah, I'm getting like 0.19 for the lower bound for some reason. I don't know what's going on.
that's what we got.
Oh, okay.
Yep, you're good.
Doubting myself.
And then for the upper 0.31.
Okay, cool. I got that too. Awesome.
Okay, sweet.
So 28.
28.
Suppose you had been in charge of designing the study, what sample size would be needed to construct a margin of error of 2% with 95% confidence? Use the prior estimate of P equals 0.2 for this estimate.
Okay. So then that's just that one formula that we're given.
That's back in chapter 17?
Yeah.
Where it's like N equals, yeah, that. N equals the square of Z divided by M, right?
Yep.
Mm-hmm.
No. I should get a calculator. I can't do this in my head anymore.
Oh, gives you.
What was your Z score?
I got negative 1.543.
I was using the Excel. My Z score is like 0 for some reason. I don't know what's going on.
Oh, actually, you gotta get the right null hypothesis. So it'd be 0.2. Would that be your null hypothesis? Yeah.
0.2, yeah, 20%. Okay, now I got 1.76. That looks good. Margin of error. We gotta find the margin of error.
The margin of error is the 0.02. That's that given number in the problem.
Right.
1537.
So I got 1,250.33. How did I do that?
So the P is just the true proportion, meaning like 50, you know?
So yeah, so P would be 0.2. In the formula.
Okay. But the margin of error is also 0.2?
No, the margin of error is 0.02.
Oh. Yeah, I got like 1250.32 or 1250.330.
Yeah.
The
It would
the
be.
an- the answers they gave us to choose from on the practice test were 2401, 1537, 16, 1801, or n is greater than 30.
N is definitely greater than 30.
Yeah.
I don't think it's any of those other ones. But
Wait, are we on 29 now or?
well, it might.
28. 28.
Oh.
So we,
I gotcha.
Okay. Did he just leave or is he Landon still here?
yeah, I'm still here.
Okay. I think I lost internet connection for like 2 seconds. That was weird.
So we can give that a try, see how it goes.
What do you guys? Wait, what's going on? 28.
For 28, I think it's 1251.
Just 1251.
Yeah,
Okay.
because you gotta, like, since it's 1250.3, you round it up to the next whole number.
Okay. Then
Okay, so 29. Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. Which of the following pairs of hypotheses is the most appropriate for addressing this question?
I think it would be the second to last.
if it's better.
That's what I got too.
Yeah.
Yeah.
Greater than.
So 29 is E.
Yes.
Yeah.
Okay, so number 30, what requirements must be met to ensure that p hat is normally distributed?
I'm gonna have problems with this one too. I mean, like,
I thought it was.
Is it A?
I thought it should be A, right? But like, because the second one just doesn't make sense. But like, what's that rule that says when you have a sufficient amount, like over 20 or something, that's good, no? Or does that only apply to the other tests?
I'm not sure. Because these are like A is the only requirements really that I've seen for any of these.
But yeah.
Like the categorical sections.
Yeah, and then the other ones for like, I'm assuming quantitative.
Yeah, I wonder if maybe that makes a difference.
Okay. The value of your test statistic.
Do you agree, Kathy? Would you put A, or what are your?
I went with B, but I mean, A makes sense. A does make more sense.
I mean, they're pretty much the same, except for the 10. No.
I put A just because it's in the book. To be honest.
Yeah.
Yeah, we'll give it a try. See what happens.
Okay. Awesome.
So this is a 1 proportion, right?
Yeah, so for that I got 1.768.
That's what I got.
Cool.
Wait, for the test statistic?
Yes.
Yeah.
So sorry, for the inputs for X, you should put like 1/10.
I put 50/200.
Yeah.
Oh, it's still that one.
Yeah. But so now all you need to change is the type of test to greater than.
Okay. Then the test statistic is your not the z-score, isn't it?
Yeah, it is. It's the Z.
Do you have to change the null hypothesis to like 0.1 or something, or is it?
The null hypothesis is still 0.2.
Okay. The z-score is still 1.768.
Yep.
Wait, is that what you guys got to? Just 1.768, or?
Yep.
Oh, okay. I don't know what I mean. It's different. And p-value was 0.039.
Yes. And then I think 33 would be A.
Yes. Mm-hmm.
Oh man, these are long ones. Next
Yeah.
few. A lot of information.
Yeah, and unfortunately, the review test in the book it's not multiple choice.
Oh, it just stops.
For the next ones?
Correct.
It just
Gotcha.
says give the test statistic and stuff.
So we have to come up with the answers. Do we want to read this out loud or just read it?
I think we can skip to the second paragraph.
Okay.
So, is this still a test of just one proportion? What kind of test is this? The true meaning. Okay. I think Landon's gone.
How's it going?
Yep, yeah. There, Kathy? Kathy?
Yeah, I'm here.
Okay. Lost our man.
Oh, you're good. Oh, right? Okay.
So we're trying to find the true mean blue score.
Thanks for coming home.
Isn't that like the
Oh, you're fine.
T-test or something?
No, it always smells.
I can't hear nothing.
Yeah, this is crazy.
I'll just wait.
So, obviously, this is the living room. Pretty nice. All the carpets new. I like the lights on the ceiling. A lot of places we look at don't have lights on the ceiling. Isn't that weird?
Family area.
Yeah, it's weird. So,
Look at the kitchen. This here is downstairs bathroom. This is a half bath. But downstairs.
you can take pictures if you want to.
Oh, okay. Yeah.
So,
So
feel free if you need to show your husband.
this is just a coat closet here. Yeah, this is the kitchen. Nice. I think it's really big. Yeah. And the laundry hookups are here. Would you be moving your washer and dryer or need to buy?
Oh, no, we have, but we're gonna buy.
So I'm gonna do this, Kathy. I'm not sure if it's right, but I'm assuming we put this data into the t-test because that's the only place it kind of makes sense.
Right, right.
Let's see what happens. Because from there, the lower bound, the upper bound, well, yeah, it gives you everything.
Right. I got 0.284 and 0.296, but I'm not going to guarantee that's even correct.
On my Excel, I got 0.282, and then my upper bound is 0.293.
Okay, hold on.
Have you memorized how to calculate it, like manually?
Yeah, I was doing all mine manually when I went through this at work because for some reason my work computer, probably because it's a law enforcement computer and it's got every bell and whistle on it, and it was reading the applet and the spreadsheets as something that it didn't recognize, and so they were thinking it was a virus, so it just wouldn't even let me do anything with it. So I had to do it longhand.
That's probably better, to be honest.
Well, I don't know.
I mean, it does. The exam did say you could use the Excel spreadsheets, though, right?
Yeah, yeah.
Yeah, because I'm just kind of afraid, like, once you move on to the next level of statistics, if you can't do it by hand, if that's just gonna like catch up to you, and like mess up your next class. So
Bingo.
yeah, it's just like how like when I took algebra, pre-calculus, and up to calculus, if you basically in calculus, you're not allowed to use a calculator. So if you didn't know how to do it by hand, you're like,
I do it longhand. Yeah.
you're just boned. There's no coming back. Oh yeah, for the degrees of freedom, I got 99.
Yeah, I got 99 for degree of freedom. I'm getting 0.283 for lower bound, though. Almost. How did I get that?
Maybe a little rounding, because that's very close to 0.282.
Well, we're going to try 282. I'm good with that.
Okay. And the test statistic, That's a really large negative number. Did you get like negative 3,683.938?
Okay, hold on. The degree of freedom was, okay, I got lost on this one because I got the degree of freedom of 99, but then I got a test statistic. I got two test statistics, both negative. One was negative 1.607 and negative 2.651. So, help.
Well, just after plugging into the spreadsheet, I have no idea how they got this number, but they got negative 3,683.938. So I just feel
Wow.
like that's a really big negative. What does that number mean exactly anyway?
The negative 3683.
The test statistic.
Let me get there.
Sometimes I've been doing my homework and just kind of like in the Excel do it, but I'd rather like know what that means. Not equal to.
Okay, now I'm just confusing myself.
Okay, my p-value was 0, but it's weird.
Yeah, I got a 0 for the p-value too.
Well, I mean, on Excel it wasn't 0, but it was like 0.256 extra zeros and then 4. So that's pretty much 0.
Okay, when I did it longhand, I got 0.111
For the p-value?
for the p-value
Oh, that's interesting.
on 38.
Huh. The null hypothesis doesn't matter, right?
Mm-mm.
Okay, but the type of test is not equal to, right?
Right.
Okay. Well, if all this is input correctly, then then that's the value is still 0.
Still 0. Okay.
Yeah. I mean, it's actually a really, really small number, but it's so small that that's pretty much 0.
All right.
Okay. So then we have, since we reject it, we have sufficient evidence to say that
The true mean is different than 0.295.
yes, because we rejected it.
So it would be C, right?
You mean A or sufficient evidence?
Oh, we have sufficient evidence.
Yeah,
Okay.
because we rejected it, right?
Let me look.
Because the p-value is lower than 0.05.
0.05.
Yeah.
So it would be A. You're right.
Cool. I think we're in the last part finally.
I had to laugh at this one. A little side note here. Because when my kids get out of bed, they're slumped. They are definitely not taller.
Yeah, I think I remember reading this a long time because we did something similar to this, right?
We did.
And I was like, not sure if your body just retracts in the morning or in the night. I mean, if you stretch, I have seen people like gain like a centimeter because you stretch.
Right.
But I can see the reason why you're sleeping. You're just kind of stagnant, not doing anything. So
Yep. They'll also do it if they use an inversion table. Hang upside down and let everything just kind of stretch out and open up. The whole spine opens up, and they can gain actually a centimeter and a half.
Really?
Mm-hmm.
That's fun. Body is weird.
Yes, it is.
All right. Well, just by looking at this, it's some kind of pair test. This is a review, isn't it?
That's where I went. I kind of backed it up. It was the African women and heights and all that. Question from a while back.
Oh. Yeah, when I look at this, it looks, because we're going back to like paired sample t-tests now with all this data. At least it is a paired sample test, right? Because the heights in the morning.
Heights in the morning and heights at night, and you're testing the same kids.
Okay. So what was the way to do it longhand?
Oh, really?
What?
Okay, hold on.
I guess I can look it up too. I have the book open right here. I'm just being lazy. I just don't remember what chapter it was. Not the ANOVA. Find that. There it is. Two means. Why is it not giving me anything?
I ended up with a lower bound of 8.728 and an upper bound of 10.455.
Right.
So what you got?
Lower bound of 8.728, and yeah, 10. And my upper bound is 10.455.
Yep.
Cool. You did all that by longhand?
Yeah, believe me, it takes me a while. I don't want to say I have a stigma with math, but I have a real stigma with math.
You don't want to say it, but you did.
Well, you know what? I have a long history of from high school. My algebra teacher was the high counselor who was over seminary, and he used to pick on me relentlessly. And every time he would say Mickey Mouse in class, I would have to stand up and sing the Mickey Mouse Club theme song. And then because I was the quote-unquote Mickey Mouse Club president, every time I had to get out to go to the bathroom or something, I had to wear this big pink toilet seat around my neck. And he affected me so mad. I have a real block with math. So it takes me a long time to do this stuff.
He scarred you for life.
Yeah, he did. He did.
Oh yeah, I can. High school teachers and middle school teachers, I feel like have a lot of influence on how we grow up.
Yes, they do, unfortunately.
I mean, your parents, number one, and church leaders do a little more than teachers do, but.
Yep. And he knew it. He knew exactly what he was doing. But anyway, that's neither here nor there. 30 years ago.
Guess I'll tell you in 30 years.
Okay, so I got a test statistic of 22.446.
Yep, I got that too.
All right.
We got degrees of freedom of 40.
Yep, I got that.
And my p-value was 0 again.
I got the p-value of 0.
Okay. Then that means, so on 45, is there enough evidence to suggest that the children are taller in the morning? So since we rejected the null hypothesis, no, we failed to reject it, right? Because it's less.
It's less than the we failed to reject the null.
Okay.
Or do we reject the null? Hold on. Children are taller in the morning. We failed to reject the null.
Okay, so we failed to reject it. So the answer is, do we have enough evidence?
You guys
No.
there?
Yeah.
Okay. Sorry about that.
No, you're okay.
So
We're on the last
don't.
question.
We know
all right.
half bath though.
What's that?
We know all about your half bath off the kitchen.
Oh man, you guys heard that? I tried to mute it, but sorry about that.
You're
Oh,
okay.
we're all good.
Hey, if you guys need a condo, it's pretty sweet.
Once I get married, I'll let you know.
All right, sounds good. Ogden's a good place.
I'm trapped in single housing.
That's funny.
Wait a minute. Where are you, Landon?
I'm in Ogden, Utah.
What part of Ogden?
Well, we're actually in North Ogden.
So do you know any of the Dixons in your ward?
Dixons?
Yes.
I don't think so.
Okay.
Let me check my LDS Tools app.
Are you active? No, I'm just kidding.
We try to be. I'm in the Elders Quorum presidency, and my wife's in the Relief Society presidency. So
Oh, you can skip it.
You really don't have a choice in the matter.
you know, we try to go to church every once in a while. Oh man.
I'm just in the bishopric. I don't need to go to church. Don't worry about it.
Are you really,
No,
Bobby?
no, I'm too young. We're adults being still chaperoned by other adults for some reason. So
Gotcha.
Interesting. I don't know any Dixons. I
Okay.
don't think so.
Well, I have an aunt and uncle, Elaine and JB Burton. They're over off of 122nd or 22nd Ave or 22nd Street or something in North Ogden. So
yeah, very cool. Yeah, it's a good place. We've liked living in this area. There's other parts of Ogden that aren't so super, but this is a good spot. So
yeah, my mom actually grew up in Ogden.
Hey, that's awesome.
I should tell you now, 75% of my extended family is in Utah, so you probably know somebody somewhere.
Darn Utah. Jeez, this place, it's like a vacuum. Sucking people in.
Okay,
cool.
so do we need to, let's back up for you then. Where did we end with you, Landon?
I'm sorry. We ended on 34.
Okay.
Like right when it started getting heavy, I bounced. Sorry.
it actually got easier after 34, to be honest.
Oh, well, that's good.
I believe it's just review. The looks of it.
Okay. So 34, did you have to use like the quantitative?
Yeah, I used
quantitative spreadsheet.
The quantitative inference procedures spreadsheet.
Okay.
And it was just I don't know how to pronounce that. That was just a one sample t-test, so you just plugged all the information in. Kathy did it manually. I did it through the Excel sheet.
You did it manually, Kathy?
Well, I was explaining to Bobby, because I did this at work, and because I work in law enforcement and their law enforcement computers, they've got every kind of virus scan protection thing on it. Anyway, the computer system was reading the Excel spreadsheet as a virus,
Oh.
so it wouldn't run it.
Holy cow, bless your heart. You understand this better than all of us now.
No, I'm not going to say that either. It took a while.
That's amazing. Holy cow.
Yep.
Right on. If you just want to run through it, I'll go back and work them out, but just for the sake of time,
Okay.
we can.
You ready?
Yeah, I'm ready.
34, we got 0.282.
282.
Yeah.
Mm-hmm.
Okay.
35, we got 0.293.
Sweet.
36, we got 99.
That one, this degrees of freedom is just like the n-1, right?
Yeah, pretty much.
Mm-hmm.
Okay.
Uh-huh.
Got you.
37, I'm still wondering what this means, but we got negative 3,683.938.
3,683.938. What?
Yeah, I don't
Oh, weird,
know.
huh?
That's a huge negative. I don't know. I just don't know. That's just what the Excel said.
Wow. Right on.
And then the p-value for 38 is 0.
Okay.
And then 39, that means we should have sufficient evidence that the true mean is different. So A.
Okay.
Cool. And then for 40, this is basically just a paired sample t-test. You just plug it into Excel and get
Go
these
from
numbers.
there. Okay.
Yeah. So for 40 was 8.728.
Sorry, what was that? You cut out.
Oh, 8.728.
Okay.
Then for 41, it was 10.455.
Nice.
And for 42, 22.446.
Sweet.
Then degrees of freedom for 43 was 40.
Okay.
The p-value was 0 again.
Okay.
So, okay, 45 I'm a little iffy on, because it says, based on your results of this test, is there enough evidence to suggest that the children are taller? So since the p-value was less than the level of significance,
Jacob?
that means we don't have enough evidence, right?
Right.
So that because we failed to reject the null hypothesis. So I put A.
Yeah.
Okay.
That's what I would put too.
Cool. Then that's it.
Nice.
I'll submit first. Let's see how bad it is.
Jacob, come
Yeah.
here.
Those first ones I'm a little nervous about.
Me too. 100, 100, 100. Oh, wow. Apparently 45 we got wrong.
45's wrong?
Yeah.
Oh, dang. Did we get 44 right?
Yeah, we got 44 right.
Oh, so we just
said it
need
wrong.
to pick something different.
Yeah, but we also missed. We got 36 out of 43, so we missed 7. No, wait.
We missed
We missed
40.
missed 7. Yeah. So we missed number 2. We missed 5. We missed 14. We missed 28. That's my fault why I missed it. We missed 37. Yeah, that did not look right. And we missed 38. Then we missed 45.
So what did you get on those questions? I know we kind of divided up answers. So like on number 2, what did you put?
I had put independent sample t-tests, which was wrong. So
I think it might just be one sample t-test because it's no, it wouldn't, because there's 2. So maybe it is paired, right? Was that what you were saying, Kathy?
Hang on, let me get back there. That's the human resources one, right? No.
That's the startup companies one.
Gotcha. Okay,
Number
hold on.
2.
So was it supposed to be paired then?
What about the chi-squared test of independence?
The what one?
Oh, yeah, that was the one where because it was testing independence, so that's why I thought it was chi-square at first.
Yeah.
Oh, I think you're right. That makes sense.
Cool. And then, sorry, I gotta input the other questions before I go on.
Nope,
So 3 is right.
So what'd you get on number 5, Bobby? What did you put there?
1 second. Number 5, I put independent sample t-test, which was wrong.
That one was wrong.
Yeah. So does that mean it was paired?
Paired samples t-test?
Yeah, for 5.
Possibly. We can put that, and then one of us can try it again.
Okay.
Okay.
And then, sorry, I have to kind of catch up. So.
No,
and then
you're
14.
Good. If you want, Bobby, we can catch you up.
I'm just reading. I have both of them open, so I can see both of them.
Oh, the second quiz?
Yeah.
Oh, okay.
I'll be there in about 5 seconds.
Cool. You're good.
Okay. So for 14, I put 0.876, which was wrong.
Oh man.
So see, I originally had 0.138 on that one.
Yeah, it's probably that one, if it's not the other one.
Okay.
And then 28, right?
Yeah, but give me a second. I just catch up. Oh, this is so much.
So, Kathy, on 14, you got 0.138.
Right.
Okay. And how did you calculate that one?
That one. I did P times, let's see, equals P times P hat minus 0.30 over 0.046 less than 0.25 minus 0.30 over 0.046.
Okay.
So Z was P hat minus 0.03 minus 0.06. N times is .10, or what was it? 109. Hold on. I can't even read my own chicken scratches here.
That's okay.
Okay, so I'm ready for 28 now, which I put 1,251, which was wrong.
Yeah, 28. I originally had 1537 on that one. Is that what was wrong?
Oh, it was oops.
That 1251, I think, was wrong.
1251.
1251 was wrong. Okay.
What did you have?
I originally had 1537 on that one.
Okay. Okay, sorry, this takes a long time to refill all this stuff.
So for the Z in that formula, did you have 1.768? Is that what you had, Kathy?
Let me find it. On 28?
Yeah. In that formula, the N equals whatever formula. Man, I'm getting the same answer, and I don't know what I did wrong.
Hold on. What did I do here? Hold on.
Oh, you know what? I think for that 95% confidence, you would use that 1.960, huh?
I got 1.195. 96. Yeah, because the confidence, the lower bound was 0.19. Oh, hold on. I'm confused.
Because I remember they gave us that table with the Z scores and the confidence levels. So like a 90% confidence level would be a Z score of 1.645, 95% would be 1.960. I think that's the one you got to use in that formula. And that by, and you got, what number did you get? I got 151537.
That's what I originally had.
Yeah, I agree. I think you're right.
For 28?
For 28, yeah.
1537?
37.
Okay.
Right.
And sorry, I have to kind of go back. So the formula you used was that N equals the parentheses Z over the margin of error squared, P parentheses 1 minus P, right?
Yes.
Okay, so were you just having problems with the right P? Or what was going on?
No, it was the right Z score.
Yeah, the right Z score.
So rather than using the Z from the spreadsheet, you got to use the Z for a 95th percent confidence interval.
Oh, yeah,
which
use
is
1.9.
Yep, 1.96. Yeah.
Okay. That's how you get 1537.
Yep.
Okay, cool.
So that makes sense.
Awesome. Then the next two that we missed was my fault.
37 and 38.
Yeah.
Right?
Man, 37.
That one was really weird. I knew that one was wrong. All in my gut. Well, I guess we have to do it by hand because the spreadsheet is not changing its ways. I plug in something wrong. Nope. I'm still getting a T of way too negative. The test is not equal to, right? The p-value is still uber zero.
Super big.
So when I change it to a greater than, the p-value becomes 1. When I change it to a less than, the p-value is 0 still. Not equal to, the p-value is still 0. My test statistic doesn't change either.
And you're using Excel?
Yeah.
I wonder if the data's flawed.
And it is a one sample t-test, right? Unless it's like a 1 proportion, maybe that's why, but
Try both. I want to try this one. See what happens.
oh, it can't be any of these. I just don't know. Did you guys plug it into your Excel too and see if you got the same thing?
I'm working on it right now. I'm going to try it and see what it gives me.
Okay.
Okay, somewhere I lost you guys.
Are you there?
There we go.
All
Yeah, I
right.
still hear you.
Holy smokes.
Did you get the same thing?
Oh, I see what's wrong. Hold on. Okay. 0. Okay. I got a T score or a T of negative 2.803 and a p value of 0.006.
How'd you get that?
I just plugged it in. What do you have for the null hypothesis?
10.
Okay, I think it's 0.295.
Oh, maybe that's fine. Okay, that's
For the
much
null hypothesis?
Yep.
Okay, that makes much more sense.
Yeah, because that's what for the okay, because isn't that what's in the information at the top?
Yeah.
For a
Yes.
test statistic of null hypothesis 0.295. Okay.
Yeah, I forgot to plug that in when I did it the first time. And then the p-value would be like, 0.00.
So then you're
6.
right.
What'd you get again, Landon? Because I'm getting a negative 2.652.
For the T?
For the test statistic.
I got negative 2.803.
Yeah, I got that too.
All right.
What type of is the type of test?
Should be a not equal to.
Type of test doesn't change that though.
Just the p-value, yeah.
I don't know.
And then the p-value of 0.006.
Yep. Well,
Okay, let's see what that does.
And then so 30, we got 39, right? Yeah, we did.
which ones you missed?
On 45.
Oh, did you change it? We got 45 wrong the first time.
So 45, 45 we would actually reject. So it'd be no because we were
Because we reject. Wait,
or
what?
based on your results, there is enough evidence to suggest that children are tolerant.
I think it might have been D.
So I think it's C.
C?
Yes.
Oh,
Because you would fail, or excuse me, because the p-value is less than the level of significance, you would reject it, which means you have sufficient evidence.
oh, yeah. And I'm boned for the test.
No, you'll be good.
Was that the only one we missed, or were
Okay.
there others?
I think so. Kathy, do you want to give it a try?
Yeah, it looks like the only one that we got everything right except for 45.
We got everything right except for 45?
Well, 45. Well, I had no because we failed to reject the null, but I think you're right. It's yes because we rejected the null.
Gotcha.
So C is probably correct.
Sorry, we should have caught you moments earlier.
That's all right. It's just one wrong. I'm happy with that.
Yeah, I just did it. We got 100.
Yay. Man, Kathy, how are you so good at determining which test is which?
I went back. I had to go back into the book and because I print everything out and I had to just decipher through. I had to go through. Yeah, it's kind of like reading police reports and court reports. You know, you have to kind of compare one to the other and
That makes sense.
try and see if it works. You know, and that's why
funny.
it took forever. But you know, muddled through it.
Nice.
Yeah, that's good. That's the one thing I'll have to review. I feel good about the other stuff, but those questions are like, man, I have no idea. So
Yeah, me too.
that's good.
So
there was one more thing we have to do, right?
Well, we're supposed to go over the our study stuff is supposed to be submitted Saturday. Our collected describe the data.
So we got to buy our tacos.
We got to buy the tacos and weights and measure.
Cool.
Well, it's funny because at Taco Bell, we're actually supposed to, like, before we hand it out, we're supposed to weigh it. So and there's the Taco Bell's goal for each taco is 3.4 ounces. And I've weighed like 1 million tacos in my life because we have to weigh every taco we send
Yeah.
out.
Seriously.
So if you want me to just grab any of those numbers.
Yeah, you could just write down 15 of those numbers and
it usually ends up between like since the well, it's not 3.4, but the hard tacos are 2.9, soft tacos are 3.4. So
are we getting hard tacos?
yeah.
Okay.
Hard taco. Yeah, the hard shells.
That's good. I like hard tacos better.
Okay.
Yeah, my kids love them. They're looking forward to this.
Yeah, it's gonna be amazing.
I start oh, go ahead.
I was just gonna say I start an eating plan next week, so I got to get all the tacos I can.
Well, tacos can be healthy. You can do fish tacos. You can do chicken tacos, tofu tacos.
Steak
and
tacos.
Actually, tofu tacos is part of it. So.
Well, there you go. Add a little chicken seasoning in with that, and you'll be just fine.
Yeah, we'll be all right.
Okay,
Nice.
so that has to be submitted on Saturday. So you guys want to shoot me some emails, maybe by Friday, with the information, and then I can put it together in a sheet
for sure by Friday, if not Thursday.
Okay, yeah, whenever.
Fair to you. So
when we buy them at the store, we're not gonna do like combos or anything, right? We're just buying individual tacos.
Individual 15. Tacos.
Okay.
Right. So we got to get the individual crunchy tacos. And I know some of them are like deluxe or whatever. Like what's a regular taco for you guys? Would you just do like lettuce and cheese?
Cheese, tomato. Yeah.
Okay.
For Taco Bell tacos, just lettuce and cheese. So.
Meat, lettuce, and cheese, you mean?
Yeah, meat, lettuce, and cheese.
Oh, okay. Yeah, I'm gonna have to because at Taco Tree they throw tomatoes on them too, so I'll just have them hold the tomatoes.
Okay, cool.
Okay, sweet. That would work.
Awesome.
Yeah. So. Then we'll shoot you some emails very soon.
Beautiful. Thank you guys so much.
And so each of us has to turn this in, I think, right? So each of us has to submit a paper.
Oh, we do?
I think that's what it said, yeah.
Yeah, we do. So I guess once you get that done, hopefully we can get them to you, like, I think by Thursday. Is that realistic if we just did that?
Yeah, Thursday's perfect.
We got them to you by Thursday. That way you could work on it. And then by Saturday, we could all...
Yeah, and then I'll email it back to you. And then you guys can just each submit it.
Yeah, so that would probably work out best.
Perfect.
Okay. So, okay, sweet, guys. Good luck tomorrow.
Thank you guys so much.
Thank you guys too. Good luck to all you.
Happy testing.
Yeah, we'll see ya.
Okay. Bye.
Okay, bye.